So now that we have calculated the overall heat transfer coefficient on the inner side Ui, what we want to calculate is the heat transfer area that is needed in order to size this heat exchanger, and from this we will then calculate the length of the tube. So we can write that the heat flux, total heat flux between the hot and the cold fluid is equal to Ui times Ai, so that's the inverse of the total heat transfer resistance, multiplied by the average difference of temperature between the hot and the cold side. The problem here is that the temperature of the hot side changes along the heat exchanger, and that's the same for the cold side. So which temperature difference do we need to use? So we can use, for example, the logarithmic mean temperature. The problem is that the logarithmic mean difference of temperature, LMTD, is defined for either a co-flow heat exchanger or a counterflow heat exchanger. In our case, we don't have either a co-flow or a counterflow heat exchanger because we have a cross-flow heat exchanger. So how do we do then? Then we can use diagrams that are giving the information about how cross-flow heat exchanger are working, and that can be very helpful for the sizing. And for this chart, the one that is provided in your exercise sheet, we get a correction factor to a difference of temperature that is calculated as if the heat exchanger was counterflow heat exchanger. So we know that counterflow heat exchanger is the most effective, so the correction factor will be, of course, below 1, to take into account that we are not in the ideal solution with the cross-flow heat exchanger. So you get this chart to find this correction factor, and in order to find the proper correction factor, you need to calculate two parameters, the P and the R parameters. And so for this you need to use the nomenclature that is related to this chart. And here you have a little plot. Here I draw it another way, where you can find the name of the variables for here the fluid that is going inside the tube, and there with the uppercase the fluid that is going outside the tube, and the one that is mixed and the other one is unmixed. So little t1 corresponds to the inlet water, little t2 to the outlet water. Uppercase T1 is the inlet hot gas, and uppercase T2 is the outlet hot gas. So in that case you can calculate P. I found 0.32. You can calculate R. I find 2.875. And with these two numbers you can look for the correction factor. So from my reading I find 0.75, but because the slope is very steep, I think there's a quite strong inaccuracy on this correction factor. So once I have the correction factor, then I need to calculate the LMTD. Here we need to use the writing of LMTD as if it was a counterflow heat exchanger. This is due to the use of this correction factor. So if you take the expression of the LMTD with as if it was a contact flow heat exchanger, you find an average temperature difference of 35.05 Kelvin. And then once we know everything, we can just calculate the inner heat transfer area, and if you do the calculation, you find 2.76 square meter. So that's a large surface that we need for this heat exchanger.